Today we're going to be assembling one of these. This is a real-time clock card. This card provides your RC2014 with a real-time clock and battery backup. Additionally, it has a jumper which is labelled Power On Reset. In setting this jumper, it means that when you power on your RC2014, it will automatically reset the CPU for you, saving you one button push. So let's go ahead and assemble our card with the lowest profile components first. We have a number of resistors and capacitors to actually solder into the board. So let's get all the components out and sort them out. So there are our capacitors, our holder for the battery, and we have the diode, and we have a number of discrete resistors and jumpers. So we will sort those out shortly. And each of these are actually labelled quite nicely, 546 and 556. We have two resistors with the same value, which are the 430Ks, and three separate resistors. So obviously it's important we put the resistors into the right place. So if in doubt, use a multimeter. The bonus of using a multimeter is if you can set it for resistance, you can quite easily tell the resistance of each of these resistors. So we know these two are 430K, so we'll put them aside. So we have three separate resistors. So that's a 1K resistor, so that's resistor number 3. So we'll get that one in first. And we'll test our next resistor. I think this is a higher one. Yep, this is the 68K, which is resistor number 5. And our final one, we'll just double check, should be a 10K resistor, which it is indeed. And our final two resistors, we'll just double check to make sure they're 430K, which they are indeed. And that's all our resistors in place. Now we have one diode to go in, which we make sure we put in the right way around. And it is marked on the circuit board. Right, now I think we'll solder those into place. Now it's always quite handy to have something to hold your circuit board while you're doing your soldering. Right, and a quick inspection to make sure all is well. And we can snip off the excess leads. Right, that's the first part of our board completed. Now we have a resistor pack to put in. And again, you need to make sure these go in the right way around. And I think we'll put a little elastic band in to hold this in place while we solder. At least we can now take off the elastic band and complete the remaining solder joints. As always, take time when you're soldering to make sure you haven't missed anything or joined two joints together with a blob of solder. It's also important to wear some eye protection when you're soldering, just in case anything spits off the board. So there we have a number of the components all in place. So next we'll look at putting in our capacitors. Now we have 4 capacitors, all of the same value to put in here, so that should be quite straightforward. We'll just snip them off their card and look to see where they go on the board. So we have 3, 4, number 1 and number 2. So that's our 4 capacitors. We'll just slot them into place. bending the legs to ensure that they don't fall out. And number 2, and the final one, number 4. So let's just solder them in place before we go any further. Now we have 2 transistors to go in here, 546 and 556, which are clearly labelled on the devices themselves. So 546 is on the left, so we'll put that one in first. And obviously there's an orientation on the transistor. So it's important we put this one in correctly. It's a little fiddly to get this one in. And the other one is 556. Now these are going to be quite fiddly to solder because the leads are quite close together. So if you have some really fiddly work to do, it's sometimes useful to have a pair of these. These are magnifying spectacles, which are particularly useful for tricky work. That seems to have got in well, that's good. Right, we'll just snip the legs off these. Right, and make sure to get all the little conducting bits of metal out of the way. You don't want any of them embedded on your board. So that's the transistors in place. So we'll have a couple more components to go in. So we will put the battery holder in. Again, we'll orientate it correctly. And we'll use an elastic band to hold it in place. And we'll get this soldered into place now. Right, that's our battery holder in place. Now we have some jumpers to get in and our sockets for the ICs themselves. Let's get these sorted out. So we have 4 ICs to go in. So we'll get the sockets organised. Go for the smallest one first, making sure we get the orientation correct. And our 2 other ones. I could probably have put the IC sockets in before the battery holder, but we are where we are. These 2 sorted out first. Sure they're flush. And we'll solder the corners of these first. Right, with the corners in place, we can now take it out of the rig and solder them flat. Right, that should be those in place. Let's just double check. Right, just one solder joint that needs a little more solder. Right, now the last 2 ICs. And we'll get these soldered into position. Right, we'll just complete the soldering of these sockets. A quick check to make sure we haven't missed anything. And all we have left to do are the jumpers and the edge connector itself. So we'll put the jumpers in first with the elastic band to hold that in place. That's the first jumper post in place. That looks fine to me. And the next one. And then we can decide which jumpers to go back in when we plug it into our RC2014. They fit quite well. Might not even need an elastic band on those. The bottom 3 in for this one. We can always adjust it later. Right, so all we need to do now is to put in the ICs themselves and then finally the battery. Now, all of these ICs are slightly different sizes, so it makes it very easy to see which one goes where. You just have to ensure you get the right orientation. And that's all our ICs in place, no legs bent. Now all we need to do is to solder on the edge connector itself. Just make sure this is level before we attempt any soldering. And we'll just put it into a rig and we'll get the remaining pins soldered into place. Right, and that's the last of the pins soldered into place. So all we need to do now is to fit our battery. Now the battery doesn't come with the kit, you have to buy the batteries separately, but these are easily obtained. And there is our battery in place. So here is our completed module. All we have to do now is to plug it into an RC2014 and set it up. So here we have the RTC card in behind our display card here. So we're going to power the unit on now. And on the keyboard, we'll hit the enter button. We'll do a list, check to see if there's any application running, which there isn't. And we're now going to paste in the source code to allow us to set the RTC clock. And there's our code going in. So this application should not only allow us to set the clock, but should display it on the segmented display at the front here. So if we run the application now, and we will not do a warm start, and it's asking for tens of hours. As it's currently 1442, we'll put 1 in for the tens of hours, 4 for the hours, 4 for the tens of minutes, and 2 for the minutes. So it's now displaying 1442 on our clock. So that's working quite happily. So we'll speed through and we'll wait until it changes to 1443. And there we now have 1443 showing on screen and on our display. So this should have set the RTC clock. So what we'll do now is we will break out of the application, we will power down the machine, so there's no power going to the boards, and the battery backup on the RTC clock should keep the clock running. So we'll give it a moment or two, and then what we should see when we power it back up is it should allow us to display it without having to put the time in. So let's power the board back up now. And we have no program, so we will now paste back in our application. And this time we can go for a warm start, which will not prompt us for the time. So if we run the application now, go for a warm start, and it does indeed say 1444. So the real-time clock has maintained our time after a power down. So I have updated our application to allow the input of the date and also the seconds, as you can see from this section here. I've run this to input the date and time, so let's do a warm start and see if our time and date come up quite happily. And there we have the hours, minutes and seconds, followed by the date in the day, month, year format. So as you can see, this real-time clock is very useful and can be accessed directly from your basic applications. Hopefully you'll find this useful in your own applications, but that's it for today. Thank you for watching.
Thank you for watching today's video. Please feel free to click on the link in the description below to discover more videos.